Welcome viewers. In this video I shall provide the solution to getting angle X and also getting angle Y. We are given two circles with centers A and B. We are also given two tangents. The two tangents touch the two circles and they both meet here. So how do we use information provided to get angle X and Y? To getting angle X, I am going to use angle in a semicircle, and to get angle Y, I'm going to use a theorem which states that the exterior angle to a cyclic quadrilateral is equal to the opposite interior angle. But then there is no information here that can help me to get X and Y. So what do? The information here is very much important. I am going to create a four-sided figure here so that I can start by getting the angle here. Now this radius I have drawn from the center, remember that it is at right angles to the what? To the tangent. A line drawn from the center of the circle that meets the tangent is at right angles to the tangent. So we have a 90 degrees here. We also have a 90 degrees here. Let's get this angle. How do we get that? Can you see this arc? It subtends 116 degrees on the circumference. Do you know that the angle it subtends on the circumference is half of the angle it subtends at the center? So if the angle here is 116 degrees, if you multiply that by 2, it gives us the angle it subtends at the center, and that will be 232 degrees. The angle at the center there is 232 degrees. So how do we get this? Remember that angles at a point is 360 degrees. So we subtract this from 360 degrees. You will get this remainder, and that remainder will be 128 degrees. So the angle there is 128 degrees. Mind you, I'm trying to get this first. Now using this four-sided figure, the sum of interior angles in a four-sided figure is 360 degrees. So how do we get this from that? We add these three angles together, 90 plus 90 plus 128. And then the answer we get, we subtract from 360 degrees. If you add those three angles together, you will get 308. So 360 minus 308 will give the angle here as 52 degrees. The angle here is 52 degrees. So next, can you see this tangent? This tangent, sorry, I'm talking about this tangent here. You know, it has the same length as this other one. The length of this is the same as the length of this, because when two tangents meet a circle, at that point where they meet a circle, their lengths are equal. So that makes this triangle to be what? Isosceles triangle. For an isosceles triangle, the base angles are what? Equal. So let's get those two angles there. Let's get this angle, and let's also get this angle. To get them, we subtract 52 degrees from 180 degrees. 180 minus 52, it will give us 128 degrees. Now when we divide that by 2, we're going to have 64 degrees. So the angle here, the whole angle here is 64 degrees. Similarly, the one here is also 64 degrees. Now bear it in mind that this tangent is at right angle to this radius, the radius drawn from the center of the circle. So the whole angle from here to here is 90 degrees. So 90 degrees minus this 64 will give what? That will give 26 degrees. The angle here is 26 degrees. Let me write it somewhere outside. The angle here is 26 degrees. Similarly, the angle here is also 26 degrees, because this triangle is isosceles, and base angles of an isosceles triangle are what? Equal. So the angle there is 26 degrees. So now to get the value of angle X, let's apply angle in a semicircle. When you have a triangle inside a circle and the base of the triangle is the same as the diameter of that circle, the triangle it forms there, the angle there will be 90 degrees. The whole angle from here to here is 90 degrees. Now we are seeing three angles there adding up to that 90. We are seeing three angles there adding up to that 90. 25 is one of them. This 26 I have gotten is also one of them. So when we add the two together, we are going to have 51 degrees. The value for X is 90 minus 51 degrees. When you subtract 51 degrees from 90, you will have 39 degrees. So the solution to our X is 39 degrees. That is the solution to X. You can see how I got that. I used angle in a semicircle. The three angles there add up to 90 degrees. I got this 26 by using this triangle all the way from here. Next, let's go on to get the value for angle Y. As I said at the beginning, the value for angle Y is the same thing as this opposite interior angle. The value for angle Y is the same as the angle here. So let's get that angle. How do we get the angle? I will start by getting the angle at the center here. What will be the angle at the center there? Remember that this is a triangle and sum of angles in a triangle is 180 degrees. Now we've gotten these two as 26 degrees each. If you add them together, you get 52 degrees. 26 plus 26 is 52. So when we subtract the 52 from 180, that will give 128 degrees. The angle at the center here is 128 degrees. Now, as I applied, the way I applied the theorem here, let's apply that. The angle, let's get the angle at the center. Let's get the angle at the center here. To get the angle at the center there, we'll subtract this 128 from 360 degrees. So the 128, 360 minus 128 gives us 232, just like this, 232 degrees. Then the 232 degrees is twice the angle it forms here. So half of 232 is 116. The same thing is happening here. So if the angle here is 232 degrees, dividing that by 2 to give us the angle here, which is 116 degrees. 116 degrees. So now this is a cyclic quadrilateral. The exterior angle to a cyclic quadrilateral is the same as the opposite interior angle. So the value for Y is 116 degrees. The value for Y is 116 degrees. The reason is that the exterior angle to a cyclic quadrilateral is equal to the opposite interior angle. Thank you for watching. Kindly share my videos and also subscribe to my channel.